Hi, my name is Nikhil Krishna Gopalakrishna. I'm a student of Purdue University Electrical and Computer Engineering. Today, my topic is natural language processing for detecting offensive content in social media. Offensive social media text has actually caused a lot of stir in recent years, like I have shown here in three different instances where they have caused riots. They have also played an important role in the capital rioting, and have also caused election results in some countries. Mixed language scenario, especially in India, where Hindi and English language texts are mixed in the Facebook posts. It classifies the post based on three main categories, that is CAG, OAG, and NAG. CAG stands for covertly aggressive, where there is an indirect reference. OAG stands for overtly aggressive, where there is a direct reference to the victim. And NAG is for all posts where there is not aggression or any offensive text present. So the models, as per the original researchers, say that they achieve 73.2% accuracy with CNN in predicting offensive posts. The other two papers were one of them, the second one uses an OLED data set where the researchers have actually curated the data set using humans to classify and make sure that the data is really classified as per what they thought, whether offensive or aggression is seen. The last paper goes to a little bit different in terms of fake news and political fact checking. The uniqueness about the last paper is that they use a different training and test data sets coming from two different sources instead of doing a training and test data split. In my research implementation, I have focused on the first paper and the second paper and used the data set from the first two papers and not from the third paper. I've used MLP, CNN, LSTM, Naive and transfer learning. Transfer learning is an extension from the original paper, which was not done in the original context. The original paper also does not have an implementation for Naive Bayes. The LSTM, CNN, and MLP were found in the original paper. The sector diagram shows how the second OLED data set is customized in order to be used with the models created from the first paper so that we don't have to rewrite all the models again. The second paper OLED database actually classifies it into three levels, but I have used only the level B and made the unintentional and intentional posts as CAG and OAG and the non offensive posts as NAG. We use three different scoring methods to find if the models are really good. One is recall, as shown here in the three different positions. Let's look at what results I achieved in the different models. CNN shows a higher training accuracy and complies with the observations of the original paper. The transfer learning actually shows higher accuracy when used with the BERT model, as in case of the second data set, whereas the first model I used Indic BERT, which had mixed language dataset training. This could probably be because the BERT model actually has a lot more data in it over the years as compared to the Indic BERT, though the Indic BERT model has been trained on different Indian language datasets. Now let's compare the scores across the different model. Transfer learning shows the best scores across all the three scoring types. CNN scores are very close to the original paper, but it's still slightly lower. The layer depth affected the MLP score, and Naive Bayes was not optimized due to lack of time in two different stages, which would have actually achieved a better score as compared to what the original paper has achieved. To conclude, the paper shows different model performance when used with both mixed code, mixed language dataset in the first dataset. And I have also shown how an English language dataset can be adapted to the same models without having to actually rewrite anything. Transfer learning was an extension that I have done to the original paper, and it shows very good performance improvement over the other models presented. A future extension of this research would be to identify offensive content in real time. And with the other, thank you for listening to my presentation and have a nice day.